So I want to talk about something that's been on my mind because I don't think it's getting nearly enough attention. In the same week that Europe was literally breaking temperature records that had stood for decades, we're talking about the hottest days ever recorded in France, the UK, Germany. Venezuela got hit by not one, but two major earthquakes within 39 seconds of each other. Over 1,000 people dead, tens of thousands missing. Now, most people are going to look at those two things and say, okay, that's terrible. But what does one have to do with the other? And honestly, that's a fair question. But here's what I keep coming back to. What if both those things have the same trigger? Because right now, the sun is doing something. It's been unusually active, and there's a growing body of research that suggests solar activity doesn't just warm the planet, it can actually shake it too. So in this video, we're going to break down what just happened with the earthquakes and the heat dome. We're going to look at what the science actually says about the sun's role in all of this, and then we're going to talk about what we can realistically expect in the months ahead. Because I don't think it's over. Not even close. On June 24th, 2026, two large strike-slip earthquakes struck northwestern and central Venezuela. The first, a magnitude 7.2, which hit at 1804 local time and was classified as a foreshock. It was followed just 39 seconds later by a magnitude 7.5 main shock. At least 1,430 people were killed, more than 3,200 were injured, and over 68,000 were reported missing. The main shock was the strongest in Venezuela since the 1900 San Narciso earthquake. The USGS pager estimates that the death toll could potentially exceed 10,000 to 100,000. Now, folks, at the same time we have this heat dome that has led to excessive heat that has been so intense and long-lasting. It is among Europe's most intense and historic heat waves on record. So let me tell you, France posted its hottest day on record, with the temperature breaking a record that was last reached in 2019. Now, one town saw temperatures exceeding 111 degrees Fahrenheit, and the heat turned deadly quickly. And because of this heat, it has been reported that 40 people have drowned since June 18th. So we have three things going on here all at once. Well, actually four things. We have two catastrophic events, the heat and the earthquakes, and we have increased volcanic activity. And at the center of it all, a star is going through one of its most active phases in decades. Now, without getting into how the sun's solar cycle works, just understand that the Earth has cycles, which we call seasons, and the sun also has seasons or cycles. The sun's seasons extend over a few years. This season, solar cycle 25, started in December. And with high sunspot numbers, frequent flares, and consistent geomagnetic disturbances, we are probably in or near the peak of the sun's cycle. The point here is that we are in the most energetically elevated period of the sun's cycle, right now, during these events. So let me try to briefly explain the mechanisms involved here. The first thing researchers noticed was a pattern in the data going back decades. When solar activity picks up, and you can measure that through sunspots, radio noise, geomagnetic readings, earthquake frequency goes up with it. Not during the absolute peak of solar activity, but during those periods when it's elevated and fluctuating. You see? That correlation or connection has been sitting in the scientific literature for a very long time. This is not some conspiracy theory, folks. It's been observed, it's been documented, and multiple independent research teams have looked at it. Now, the next question is, why? The first one involves something called the piezoelectric effect. When a surge of protons from the sun hits Earth, researchers found that earthquakes above magnitude 5.6 spiked within the following 24 hours. Remember that. When a surge of protons from the sun hits Earth, earthquakes above magnitude 5.6 spiked within the following 24 hours. Now, the reason this happens is that quartz, which is extremely common in the Earth's crust, can generate tiny electrical pulses when it's compressed. So if solar protons are triggering those pulses in rock that's already under stress, it could be just enough to push a fault over the edge. The second explanation comes out of Kyoto University, where scientists built a theoretical model showing that solar flares disturb the ionosphere, and that disturbance creates electric fields that can actually penetrate down into fault zones deep in the crust. Again, if a fault is already close to breaking, that extra electrostatic pressure could be the thing that makes it go. Third, and this one connects directly to the heat wave, solar heat changes atmospheric temperatures, which in turn affects the physical properties of rock underground. It can make rock more brittle, and so it's more likely to fracture. It also shifts rainfall patterns and snowmelt, which changes the pressure on tectonic plate boundaries. So the same solar energy that's baking Europe right now is also conditioning the rock beneath our feet. And then there's a fourth mechanism that's a little harder to visualize. Intense solar activity changes how fast the Earth is rotating. Most people don't know that. And those tiny accelerations can affect natural electric currents that flow through the ground. Either of those things is enough to trigger earthquakes. So what you have here is 5 different pathways, 5 different research teams working independently, all arriving at the same basic conclusion from different angles. The sun is heating us up, and it is actively interacting with the ground we're standing on. Now, the reasoning you're going to hear for all of this is climate change. Whatever. If you believe that, then that means you don't believe the science. You believe mainstream science. And that means you also believe that mainstream science would never lie to you or withhold relevant information or data. Now, here's the part I really want you to pay attention to, because there's a misconception I see a lot when people talk about solar cycles. The solar maximum for this current cycle, solar cycle 25, hit in October 2024. So technically, we're now in the declining phase. And a lot of people hear that and think, okay, so we're past the worst of it, right? But that's not how this works. Think about it like a hurricane that's already made landfall. Just because it's weakening doesn't mean the flooding stops immediately. The sun can still throw massive flares years after its peak. We've seen this before. Solar cycle 23 peaked back in 2001, but some of the biggest, most destructive flares of that entire cycle didn't hit until 2003 and 2005. That's 4 years after the peak. So if you're thinking we're in the clear, think again. So what you should actually be watching for in the coming months, 3 things. First, keep an eye on solar flare alerts, specifically X-class flares, which are the most powerful category. Those are the ones most likely to send big proton bursts toward Earth. Second, pay attention to geomagnetic storm warnings. And third, watch global temperature anomalies, because extreme heat may also be a signal for the same solar activity that's stressing the ground beneath us. Now, there are some other things to be aware of that are very important. So let me quickly break down everything beyond heat and earthquakes that the sun can affect heading into July and the following months. When a burst of charged particles from the sun slams into Earth's magnetic field, it can actually push electrical currents into power lines on the ground. Those currents can overload transformers and trip breakers, which in a worst case scenario means widespread blackouts. That's a particularly scary thought in summer when power grids are already straining under the weight of everyone running their air conditioning. Satellites, the radiation from a big solar flare can fry the electronics on board, degrade solar panels. It can shave years off a satellite's working life. In an extreme event, some satellites could just fail, and if they fail, services we depend on fail with them. GPS, weather forecasts, communications, and it would be a long time before those things are fixed. Speaking of GPS, even a moderate solar event can mess with those signals as they pass through the upper atmosphere. You might be only off by a few meters, or you might lose the signal entirely. Either way, that matters a lot when you're talking about shipping routes, flight paths, military operations where precision matters, right? Aviation in general feels the effects of space weather more than most people realize. Solar events can systematically cause flight delays, and polar routes are hit the hardest since that's where the sun's radiation has the strongest influence on the atmosphere. Now, this is probably one of the last things most people would think to connect to solar activity, but the research is there. It turns out geomagnetic storms actually affect the human body. There is a connection between periods of high geomagnetic activity and a spike in heart attack hospitalizations. That's not just a claim, it shows up in the data. Mental health is another area where the effects seem to show up. There was a study done called Geomagnetic Storms Association with Incidence of Depression as Measured by Hospital Admission, which found that hospital admissions for depression were 36% higher in men in the 2 weeks following a major solar storm. The working theory behind this is that geomagnetic activity can throw off the balance of serotonin and other neurotransmitters, which could explain why some people feel more irritable or anxious or emotionally off during periods of intense solar activity, even if they have no idea a storm is happening. Sleep can take a hit too. Some researchers think geomagnetic storms interfere with the body's internal clock, so the result could be restless nights and mood shifts that feel a bit like jet lag, except instead of a long flight, it's the sun. Most people know that animals can sense things humans can't. Take bird migration. Fewer birds take flight during strong geomagnetic disturbances, And the ones that do migrate seem to have a harder time finding their way, particularly in autumn when skies are overcast and they can't rely on the stars or sun for backup navigation. In other words, a solar storm can disrupt migration patterns across entire populations at once. Whales and dolphins appear to be vulnerable in the same way. And so we end up with whales and dolphins beached or they can't find their way around. When extra solar energy warms the surface of the ocean, it sets off a chain reaction. Sea surface temperatures influence where storms track, how the jet stream positions itself, and how well the major ocean circulation systems in the Atlantic and Pacific keep moving. Those systems are already under stress right now, so adding more heat to the equation isn't helping. On land, there's drought. Europe already had a dry spring, so the topsoil has lost so much moisture that the ground can barely cool itself anymore. This solar activity makes it worse because it's going to lock in patterns that block rain from moving in and keeps heat trapped in place. What that means is that dry conditions are going to stretch well into the fall season. Then there's the wildfires. It's so bad right now that a single spark, someone throwing a match, can turn into something very difficult to control very fast. Energy from solar flares can disrupt high-frequency radio signals to the point of a complete radio blackout on the sunlit side of the Earth that would affect air traffic control, the military, emergency responders. But because of national security, they don't really tell people about how the sun can affect flights. Keep that in mind. Look, again, solar cycle 23 officially peaked back in 2001, but the most powerful flares of that entire cycle didn't arrive until 2003-2004, years later, triggering back-to-back G5 geomagnetic storms that were so intense they were visible at latitudes nowhere near the poles. So even though the cycle back then was supposed to be winding down, it wasn't done. So where does that leave us? Well, there's going to be risk with power grids, human health, wildlife, weather systems, global communications, all at once. Every system we have built, every network we depend on, every creature that navigates by instinct, every heartbeat regulated by chemistry, all of it exists inside a magnetic bubble that the sun can shake up whenever it decides to exhale. Anyway, folks, that's going to be all for now, and there is more to come. Please click the thumbs up button and like this video. Join us over on Patreon. It's free to sign up. You can also catch Woodward TV content on the platforms listed in the description box below. Also, let me know what you all think about this in the comments below. Everyone have a great day, and as always, stay awake, stay aware, stay safe, and I'll talk to you all soon.